Alright, hi guys. We're going to talk about this thing called binomial expansion and Pascal's triangle. So here, what you're going to learn is how to create and use Pascal's triangle to expand a binomial. So we're going to talk about what a binomial is, and a binomial is a polynomial with two terms. Alright, here's an example. 3x plus 7, one term, two terms, and that's a binomial. Alright, binomial expansion means to expand a binomial through a multiplication. I don't know why I keep saying that. Alright, it's to write a binomial in a equivalent form. So here's an example. So if I do this, so this is my base, which is 2x plus 7, and that exponent up there tells me to write that 2 times. And what a binomial expansion would be me multiplying this so I can expand that binomial out. Now we can use FOIL or the box method. And what makes different about what we're going to talk about today is how do we deal with situations that are greater than 2, because they take a little longer to write out and multiply. So we're going to focus on when a degree is greater than 2 and how do I expand that binomial. So in other words, how do I multiply that binomial? Okay, so a leading coefficient is the number in front of the variable with the highest degree. The number in front of the variable with the highest degree. Okay, here's an example. So we get 7x squared plus 4x minus 2. So the highest degree here is 2, so the leading coefficient would be 7. Okay, a variable is a letter that represents a real world situation or object. And this can be done with X, Y, Z. You can use the whole alphabet if you want to. Okay. Exponent, power, degree, we already know these, so I'm going to skip that. The base is the biggest, and this we went over in another class. Let me say it this way for you. It's the number below the exponent, power, or degree. They all mean the same thing. Okay, here's an example. 3 squared. 3 is the base. If I do 3x all squared, 3x is the base. If I wrote something, and if I wanted to rewrite this where the squared was distributed to both variables, you put a 1 there and you would multiply the variables. So here you get 3 squared x squared, and here the base is both 3 and x. So same thing. So Pascal's triangle is a method used to help with expanding a binomial. Okay, it's a method used to help with expanding a binomial. And then we'll go from there. Alright, so that's our key vocab. So let's go ahead and jump into a problem. Well, let me show you how Pascal's triangle works. On some assessments, you won't be given this triangle, so if you need to expand a binomial, I'm going to show you how to do it. But in our course this year, we will give you Pascal's triangle, so you don't have to worry about memorizing it, but I am going to show you how it's created. So for the first row, or the zeroth row, we just put 1. And this out here means the exponent. This is the exponent. And they call it the row that matches the exponent. So we'll just say that. Row that matches the exponent. It's the row that matches the exponent. So if the exponent is a 0 power, you use this row. The exponent is the first power, you use this row. So how are these rows created? Well, we started off with the 1, and then we write another set of 1s. And then here, when we get to what they call the second row, then we write a 1 and then do 1 plus 1 is 2. And then you write a 1 at the end. Then you put another 1, and then you put 1 plus 2 is 3. 2 plus 2 is 3, and then put a 1 at the end. And then to get the fourth row, you do 1. 1 plus 3 is 4. 3 plus 3 is 6. 3 plus 1 is 4. And then there's 1. And you can keep this going all the way down for as many exponents, for as many rows you need to match the whatever the exponent is. Here I'm just going up to 6. In this class, we're going to stop at row 4. So you won't have to worry about anything past that in this class. Alright, so this one says expand the following binomial, where the base is x plus 4. And the exponent tells us to write that base 4 times. So okay, so now you need to go in and see, all right, what row should I be on and what exponent matches this row? So the fourth row matches that exponent up there. So I am going to go and write down these coefficients, or these integers right here. So I'm going to put 1, and then I'm going to just put a space. And since that's a plus sign, I'm going to put plus here. And then I'm going to write the next number is 4. So I start with this. Oops. So I start with So I start with 1, and then I write my space, and then I'm going to do 4, which is what I just wrote, and then I write 6 next, and the sign that goes there is going to be plus because the sign is plus, and then I'm going to put 6, draw it out, and then, wait, I need to draw this, I need to write this neater. Give me a second, guys. You keep yours in your paper, but I need to scoop mine over. So I'm going to do 1 line plus 4 line plus 6 line plus 4 line plus 1 line. Alright, and now I got all of those numbers from the fourth row because it said the fourth exponent. So this is the row of the exponent. And then I'm going to start with this x. So I'm going to write x, and I'm going to raise it to whatever the power is, x to the 4th. And then I just decrease 1, x to the 3rd, x to the 2nd, x to the 1. And then I can write x to the 0 here, but I'm going to show you guys something. X to the 0, anything to the 0 power is 1. Check it out. Try your age. So most of you might be 16, maybe some 17. Try 16 to the 0 power and see what it equals. And then try 17 to the 0 power and see if I'm telling you the truth that this equals 1. So we don't write the x to the 0 there because it's going to be equal to 1. And then here, I'm going to go to the second number, and I'm going to put 4, but this time, I'm going to start it with 0. So the second term starts with 0, and then I'm going to increase the number. So 4 to the 1 is next, 4 to the 2 is next, and then 4 to the 3 is next, and then 4 to the 4 is after that. And if you want to put x to the 0, you can. It doesn't hurt anything. We're going to get rid of it anyway, but just to keep it consistent, you can write it. And now I'm going to do the math for each one. You can use your calculator to help you. We're going to multiply the coefficients. So to get your calculator, just go to, you could click on your PDF and get to decimals. I'm just going to type it into the calculator. Yeah, I'm going to just go to decimals so it'll look like yours, and then go to math tool and click scientific calculator. And that was 1 times 4 raised to the 0 power, and that equals 1. So here, then this is going to be 1x to the 4th plus 4 times 4 to the 1. I'm going to use the math in my head, or you can use the calculator, whichever one works for you. Plus 6 times 4 squared is 16. So 16 times 6 is going to be 16 times 6, 60, plus that should be 96. And I'll go back and check myself just to make sure. So this is 4 times 4 raised to the 2nd power. Stripping 64. Oh, because it's not 4, it's 6. Oh, okay. So it's 96 x squared plus 4 times 4 raised to the 3rd power is 256. 256, and this is going to be x to the 1st power. And then you're going to do 1 times 4 to the 4th. And then remember, x to the 0 is just equal to 1. And now I can show you guys what I was saying about raising anything to the 0 power. So if I do 5 raised to the 0, I do 1. If I do you guys' age, what about 16? 16 raised to the 0 is 1. And you can keep seeing that's to the 1. Anything raised to the 0 power is 1. So here I'm going to do 1 times 4 raised to the 4th power is 256. Alright, so then we get 256 on the end, and we're done. We expanded that binomial. This is your answer right here. So that is a whole lot quicker than having to do the box method. How many times? 1, 2, 3 different times. When you can use Pascal's Triangle and you got it. Alright, let's go to this one where we do the 3rd power. Now here, I'm going to look and see. This is telling me to do x times 4, x minus 4 times x minus 4. It means to write that 3 times. Now this tells me to look for the exponent row 3. That's right here. So I'm going to write the coefficients out. I'm going to put 1, draw my line. But since this is a minus sign, I'm going to do minus. And then 3, draw my line. Now, I'm not going to write minus again. I'm going to alternate from minus to positive. So I'm going to say plus. So this one matches this one. This 3 matches that 3. Alright, now this next 3 I'm getting ready to write is going to match this 3 right here. Okay? And then I'm going to draw the line. And then I'm going to alternate that sign. And that last one matches this one right here. Okay, so just be careful with the minus sign. The signs alternate with the minus. So plus, so you do minus plus, minus plus. Alright, so you do alternate that sign. Okay, so now I'm going to start with this x, and I start with the highest degree, which is 3, and then x to the second, x to the 1, x to the 0. Then I start with the 4, 4 to the 0, 4 to the 1, 4 to the 2, and then 4 to the 3. Okay? And then we're going to go do our math. 1 times 4 to the 0 is going to be 1. Keep the minus sign. 3 times 4 is 12. And that's going to be a negative. 3 times 16, because 4 squared is 16. 16, 3, that's 30 plus 18. So that's going to be plus 48 x. And then negative 1 times 4 to the third. X to the 0 is 1, so you don't worry about that. So you just go use your calculator and do negative 1 times 4 to the third. Well, I know that 4 squared is 16, and then 16 times 4, that would give me 40 plus, so that would be 64. So minus 64. You can use your calculator to check behind me. But that is it. And you're finished. So that's using Pascal's triangle to quickly expand a binomial. Okay, you guys have 2 homework problems to complete on your own. Please knock those out, and then I'll see you in class and we'll talk about it.